Imagine downloading, like, a brand new, beautifully formatted ebook.
Oh, yeah. Always a good feeling.
Right. So you settle in to read, you flip to chapter 3, and right in the middle of this pivotal scene, the dialogue is it's abruptly cut off by this robotic string of text.
Like a system error or something.
Yeah, exactly. It literally reads, verbosity level 3, processing paragraph 42, memory allocation stable, and then the story just continues as if nothing happened.
Wow. Yeah, that completely breaks the immersion.
It really does. That jarring, broken experience
Mm.
is exactly what happens when digital tools fail to separate their messy internal thoughts from, their polished final product. So today on the deep dive, we are looking at how to prevent that exact disaster.
And we have a really fascinating source for this today.
We do. We're examining a hyper-specific blog post by a developer named Ang. It's titled Notes on Haskell Programming, Part 157, Moving Debug Output to stderr. And this was published on June 9, 2026.
Which, I mean, it sounds incredibly niche on the surface, right?
Oh, totally.
We're looking at part 157 of a developer's highly technical diary about the Haskell programming language. But the mission of this deep dive isn't to teach you how to write code.
Definitely not. I mean, I'm not a programmer myself.
Right. Our goal is really to unpack this single, seemingly tiny line adjustment that Ang made in this post. Because, well, embedded in that one adjustment is this profound architectural philosophy about how computers and, frankly, how any well-organized systems process, filter, and route information.
Here's where it gets really interesting. Reading this entry doesn't actually feel like looking at a boring technical manual.
No, not at all.
It feels more like examining the blueprints for clean, elegant software engineering. Even if you have zero technical expertise, understanding this concept fundamentally changes how you look at the tools you use every day.
Exactly. We're basically looking at the mechanism that keeps the noisy, chaotic engine room of a program completely separate from the quiet passenger cabin.
I love that analogy. But to understand where a program sends its text, we first have to understand when and why it decides to speak up in the first place, right?
Yeah, which brings us right to the first part of Ang's code snippet.
Right, the post zeroes in on this concept of verbosity.
Yeah, so the snippet Ang shares hinges on a specific function designed to print text. It's written as print content verbosity and then tparagraph txt in parentheses.
Okay, so that's the command to speak.
Exactly. But what's critical here is the condition Ang wraps around it. The code explicitly dictates that this function should only run when verbosity is greater than or equal to 3.
So there's a strict rule there.
Yeah, the text clarifies this is completely intentional. The system is instructed to only show these paragraphs if the verbosity setting is high.
If you're trying to visualize what verbosity means in a practical sense, think about hiring a private tour guide for a museum.
Okay, I can picture that.
If you set your tour guide to verbosity level 1, they're going to give you a highly efficient, completely stripped-down experience.
Right, just the bare minimum.
Exactly. They walk you into the room, point to a painting, say Leonardo da Vinci, and then just walk to the next room. They deliver the primary product, the identification of the art, with zero friction.
And honestly, for most visitors, that frictionless experience is exactly what they want. They don't want to be bogged down, they just want the answer.
But if you crank that same guide up to verbosity level 3, you are suddenly in full diagnostic mode.
Oh boy.
Yeah, the guide stops at that same painting and just gives you a mountain of meta information. You get like a 10-minute lecture on the chemical composition of the blue paint.
The type of wood used for the canvas.
Exactly. The artist's childhood, the temperature of the room during the restoration process, all of it. Now, looking at Ang's code, that when verbosity is greater than or equal to 3 part, I actually have a real problem with the underlying philosophy here.
Really? How come?
Well, the program is only revealing these dense paragraphs of process at level 3. That implies that at levels 1 and 2, it's actively hiding its own steps.
Oh, I see what you mean.
Right. In a technical environment where we constantly talk about valuing transparency, why would a programmer deliberately design a system to conceal its own internal state by default? I mean, why not just stream all the data all the time, so you always have a complete picture of what the system is actually doing?
Well, what's fascinating here is the sheer scale of the data we're talking about and how human cognition completely breaks down under information overload.
Okay, fair point.
If you force a system to expose every single microstep, the actual deliverable just gets obliterated by the noise. Think about a standard file conversion. The computer is executing thousands of tiny operations.
Like what kind of operations?
Allocating memory, reading text encoding, structuring fonts. If it prints a line of text to your screen for every single one of those micro operations, the final output you actually asked for, maybe just a simple confirmation that the file was saved, is totally buried under pages of scrolling text.
Oh, right, like trying to find one specific email in a spam folder. So it's not about secrecy, it's really about protecting the user's attention span.
Yes, exactly. It's about utility. Eng's code snippet perfectly demonstrates that a mature program aggressively separates its primary function from its meta-commentary.
It keeps the engine room away from the passengers.
Right. The program still does the heavy lifting, it still performs the calculations, but it intentionally silences its own internal monologue. It hoards those high verbosity paragraphs, the dense museum guide lectures, and only unleashes them when a developer explicitly flips the switch to level 3.
And I'm guessing a developer only flips that switch when the system actually breaks.
Precisely. When the file refuses to save, they need to see that internal monologue to pinpoint exactly which microoperation failed.
That makes the tparagraph txt part of Eng's code even more significant, I think. We aren't just talking about a tiny error code popping up like a brief, error 404.
No, not at all.
The use of the word paragraph implies a substantial block of text. If you let multiple paragraphs of diagnostic thoughts stream out into the open every single time the program runs, you're creating a massive fire hose of text.
A completely unmanageable flood.
Exactly. So if verbosity level 3 creates this absolute flood of diagnostic thoughts, where does it all go? If it's not managed, it's just going to wash over the screen and drown the actual product. How does Eng actually catch and direct all that runoff?
Well, this is where we transition from the theory of verbosity to the hard mechanics of data routing. Eng's post details a critical refactoring of the codebase to solve this exact problem.
Okay.
The post outlines a shift from using a standard function called hPutStrLn to a highly specific function called hPutStrLn.
Okay, let's unpack this because this single letter addition is really the linchpin of the whole operation.
It really is.
In the source material, Eng brings in some new tools from a system library called system.io. The text explicitly points out that the code imports hPutStrLn alongside a target destination called stderr.
Yes.
And Eng notes that the H at the beginning of that new function stands for handle.
Right, and that concept of a handle is doing the heavy lifting for the entire software architecture here. As Eng explicitly states in the post, utilizing that handle tells the Haskell runtime environment to deliberately bypass the standard output stream.
Which is the normal path.
Exactly. It bypasses the standard stream and instead forces that data down the error stream.
If you were trying to picture this handle mechanism in your head, I think moving away from software for a second and looking at physical plumbing is the best way to understand it.
Oh, I love a good plumbing analogy.
Right. Imagine the original function, hPutStrLn, as a wide-open kitchen faucet. When you turn it on, the water pours straight down the main drain of the sink. In computer architecture, that main drain is standard output. It's the default path of least resistance.
Basically, anything the program has to say naturally flows down that main pipe.
Exactly. But adding that H, modifying the code to hPutStrLn, is the equivalent of physically attaching a dedicated heavy-duty hose to that faucet.
Oh, I see.
Yeah, that hose is your handle. You are no longer letting the water fall into the main drain. You are actively routing it through the hose, bypassing the sink entirely and aiming it at a completely different drain on the other side of the room.
You're taking complete manual control of the flow rather than just relying on the default gravity of the system.
But here is where the terminology Eng uses really trips me up.
How so?
Well, the text states that we are sending this debug info, these verbosity level 3 paragraphs, to the error stream stderr. That feels like a massive misnomer to me.
I mean, I get why you'd say that.
Right. A chatty museum guide giving me the historical context of a painting is not an error. A program explaining how it's formatting a paragraph is not a system crash. The program isn't failing. So why on earth are we forcing perfectly healthy, non-critical diagnostic logs into something called an error stream? It just feels like terrible naming conventions.
If we connect this to the bigger picture of computer architecture, your frustration with the terminology is honestly entirely justified.
Thank you.
The name stderr is actually a historical artifact from the early days of computing, and it is definitely misleading to modern ears. But it is crucial to understand that stderr is not exclusively reserved for fatal crashes, kernel panics, or, catastrophic failures. In actual practice, it functions as a parallel secondary channel.
Okay, so it's less of a panic button and more of, like, a dedicated service elevator.
That's a fantastic way to look at it. Standard output, that main drain in your sink, is exclusively for the actual intended product of the software. If you write a program that calculates prime numbers, the numbers themselves must go to standard output.
Makes sense.
Stderr, despite its dramatic name, is simply the designated channel for the program to talk about its own process. It's the meta channel.
Ah, okay.
So warnings, progress updates, high verbosity debug logs, and yes, actual system errors, all of that meta commentary goes down the stderr pipe. The entire architectural philosophy is to ensure that the meta commentary never pollutes the main channel where the clean final product lives.
That level of structural organization makes so much sense. You build a separate pipe for the messy stuff. But let's see the actual blast radius of this code change.
Let's do it.
Because what happens when someone actually tries to use this tool? Ang doesn't just leave us with a Haskell syntax. The post provides a highly practical look at the command line interface to show us the consequences of this routing.
Right. The post uses a specific tool for its examples, a program called XS2 ebook. And based on the syntax, it's a utility that converts standard text files into formatted electronic books.
Which perfectly aligns with our earlier scenario about ruining a novel with robotic text.
Exactly.
So the first command Ang highlights is this XS2 ebook -f PDF novel.txt novel.pdf. Now, for anyone who uses command line tools, that greater than symbol is standard operating procedure.
It's very common.
Yeah, we know we're feeding a text file into the program, asking for a PDF, and the greater than symbol simply grabs the standard output and saves it directly to a file called novel.pdf. You just bypass the screen and drop the product right into a file.
But Ang immediately follows that up with a second command. And this is where the brilliance of explicitly writing to stderr in the code really reveals itself. The second command is the same at first, but then adds something. It's XS2 ebook -f PDF novel.txt novel.pdf2 debug.log.
Wait, so what does this all mean? We have the exact same command on the front half, generating the PDF, but Ang has appended to debug.log to the very end of the string.
Yeah, so the post explains that this to addition allows the user to explicitly exclude the debug log from the main operation and capture it in a totally separate text file. In command line environments, the number 1 represents standard output, and the number 2 is the universal identifier for standard error.
Oh, so returning to our plumbing analogy, the first greater than symbol catches the clean water, the final PDF from the main drain, and bottles it up.
Exactly.
And the 2 symbols, the second bucket, it catches whatever's coming out of that dedicated hose, all those verbosity level 3 sticky notes, the chatty museum guides lecture, and bottles it up in a separate container called debug.log.
You've got it. You are simultaneously capturing the pristine final product and the messy, highly detailed diagnostic process without ever letting them touch each other.
But let's look at the alternative for a second. If Ang hadn't bothered to make this adjustment in the Haskell code, if Ang hadn't deliberately added the H to hPutStrLn and explicitly imported stderr, what is the actual consequence for the person running that first command?
It's not pretty.
Does the computer just, figure it out? Or would it literally shove all those verbosity paragraphs right into the pages of the final PDF?
The computer will never just figure it out. Computers do exactly what they're told.
Fair enough.
Based on the mechanics Ang lays out, without that explicit handle routing the data to stderr internally, you have an architectural failure on your hands. If everything defaults to standard output, then your high verbosity debug logs and the actual text of your ebook are flowing down the exact same pipe.
So they become indistinguishable to the system.
Completely indistinguishable. When the user executes that command to save the output to a PDF, the system grabs everything in the pipe. You get a corrupted, hopelessly mixed up result.
Like we said at the start.
Yeah, you'd open your newly generated ebook, and right in the middle of a sentence, you'd find raw code spitting out memory allocation stats or paragraph processing times.
Which renders the tool entirely useless. If you're a user trying to automate a batch of 100 books, and the program corrupts every single file with its own internal monologue, you're going to abandon the software immediately.
Oh, without a doubt.
To fix that without Ang's internal code change, the user would have to write complex, fragile filters on the command line just to scrub the debug text out of their own novel.
And that is an unfair burden to place on the user. This really highlights the true empathy of what Ang is demonstrating in this post. Good code anticipates how the end user will interact with the tool.
That's a great point.
A lazy developer lets everything pour out of standard output and makes sorting the mess the user's problem. But by taking the cognitive load onto themselves, by importing system.io, writing the conditions for verbosity, and explicitly utilizing the handle for stderr, ensures that the user's default experience is pristine.
They get a clean product.
The user gets a clean PDF on the outside every single time because the developer managed the plumbing on the inside.
It's the ultimate form of digital hospitality. You do the hard, meticulous work of organizing the pipes inside the walls of the code base so that when the user turns the faucet, they don't get a face full of blueprints and diagnostic tools. They just get clean water.
Exactly. It's the rigorous enforcement of boundaries. The process must never contaminate the product.
Let's take a step back and distill this journey because we've covered a lot of architectural ground today.
We really have.
We started with what looks like an obscure, hyperspecific diary entry about adding a single letter H to a Haskell function. But by unpacking that syntax, we uncovered a masterclass in routing information. We explored the concept of verbosity, the idea that a system possesses a dense internal monologue that it can either suppress or broadcast.
And we looked at handles, right? Those dedicated hoses that bypass default pathways.
Yes. And most importantly, we saw how that internal discipline separating standard output from standard error inside the code empowers the end user. It allows a simple command like to flawlessly capture the messy diagnostic logs without ever risking the integrity of the final product.
And, this philosophy extends so far beyond command line interfaces or the Haskell programming language.
Oh, absolutely.
If you think about your own workflow, whether you're drafting a complex legal brief, organizing a massive spreadsheet, or outlining a creative project, intentionally separating your messy process from your final output is the absolute baseline for clarity.
It's so true. You need a dedicated, chaotic space for your half-baked ideas, your sticky notes, your verbosity level 3 thoughts. But you must build a firm boundary to ensure those notes never accidentally bleed into the polished work you present to the world.
Ang's refactoring is really just a digital, perfectly executed manifestation of a very human need for organization.
It really comes down to managing cognitive load. When we mix our drafts with our final versions, we just create friction and confusion. Clean systems, whether they are built of code or built of human habits, rely on knowing exactly where the product ends and the process begins.
Well said.
We've spent this entire deep dive exploring how a well-designed program beautifully separates its primary deliverable from its own high-verbosity internal monologue. It gives the software a dedicated space to process its thoughts without overwhelming the user.
Yeah, it's pretty elegant when you think about it.
It really makes you wonder, as we navigate our own digital lives, constantly bombarded by fragmented texts, notification badges, and a never-ending stream of emails, are we failing to make this same distinction?
Oh, that's a good question.
Are we constantly mixing up our own messy debug logs with our primary meaningful output? Just imagine how much clearer our lives would be. What would it actually look like if human communication had a built-in slitter channel, a dedicated space to dump our noise so our main messages could finally remain completely clean?